Hey students, in this lesson I'm going to be covering writing real-world equations for your Unit 1 test. So for this particular test, I'm going to show you that the word problems are going to seem kind of long, maybe a bit intimidating, but once you break things down, it's really not too bad. Okay, so let's read this one. To find the gravitational pull G on any planet, use the equation G equals ma, where m is the mass of the object and a is the free-falling acceleration. So I'm just going to highlight this equation right here. Every word problem is going to have some sort of equation that you're going to have to deal with. It says a planet has a gravitational pull of 5 meters per second squared, and an object on the planet has a mass of 8 kilograms. Write an equation to determine the acceleration. So I would encourage you to focus mostly on the numbers that they're giving you here. So I see there's 5. This label is not very important for what we're doing in our class. You can just focus on the number in front of it. And then we also have the number 8. And so from the keywords, 5 is being identified as the gravitational pull, and 8 is being identified as the mass. And what we essentially want to do is figure out where we're going to plug in those two numbers into the equation that they gave us. So going back to the first part, it says that gravitational pull is represented by the letter G, and that the mass is represented by the letter m. M is the mass. So taking that original equation, G equals ma, all I'm going to do is plug in the gravitational pull of 5 for G. And I'm also going to plug in that 8 is the mass. And we can use this equation to determine the acceleration, but it actually doesn't ask us to solve for it from here. And so this is actually all we have to do to finish writing an equation that helps us determine the acceleration, and that is our final answer. Let's try another one. We've got, a lot of words here that are basically representing this equation. We, at this point, don't need to know what this equation fully represents, but it says PV equals nRT. It tells me what each of those letters represent. After that, let's see what other information that we're going to have to plug in. So suppose it has a volume of 10 and a temperature of 32. So I'm going to plug those into the PV equals nRT equation. So it says up here that V is the volume and that T is the temperature. So I'm going to replace 10 for V and 32 for T. And the rest of these are just being multiplied out. P times 10 equals N times R times 32. Excuse my handwriting. But the only thing that I would change about this is we usually put numbers in front of variables. So this would probably be written on your test as 10p, because you can multiply things in any order. And then they probably would move the 32 to be in front of N and R as well. And this is our final equation for this example here. So for the third example, they actually didn't give us an equation in the word problem, but we do have some multiple choice options here that are going to help us be able to narrow down what's going to work. So Tasha went for a run one morning, averaging 6 miles per hour. She began running 0.5 hours ahead of her roommate, Alicia. Suppose the variable D represents Tasha's total distance and T represents the number of hours since Alicia started. So I'll kind of highlight those points there. So D is Tasha's total distance, whereas T is the number of hours since Alicia started running. So I actually really like to just kind of break down word problems like this by drawing a diagram. So let's just start with Tasha. So let's say Tasha starts running at, doesn't really matter what time you choose. I'm just going to say she starts running at 12 p.m. so we can kind of keep track of this easier. She starts and she's going some time. then she's running for a few hours, let's say to 1 p.m., 2 p.m., we'll say she stops at 3 p.m. or so. And obviously that's not in the word problem, but we're just doing an example here. Now she runs 6 miles every hour. And so that means in the first hour, she's going to go 6 miles. In the second hour, she's going to go a total of another 6 miles, but she'll end up at 12 miles. And then another 6 miles after that, she'll end up at 18. Now, her roommate, Alicia, is actually starting at 0.5 hours later. And so she's going to start here at 12:30, 0.5 hours later, 12:30. And it says in the word problem that this is actually where we want T to start. This is where T is going to be. So let's kind of see if we can just write an equation that deals with Tasha. So she is going, let's say she ends after running 18 miles. That's the total distance she's run, 18 miles. And we get that she runs 18 miles by going her miles per hour times the number of hours that she has ran. She ran 6 miles per hour for 3 hours. But by the time Tasha has ran 3 hours, Alicia has only gone 2.5 hours. She's gone half hour shorter, right? And so we need to take the amount of time that Alicia has ran and add the 30 minutes before that to make up for the time that Tasha has. So instead of writing 3, I guess you could kind of write it as 2.5 hours plus that 0.5 hours before to represent how Tasha would be running. And so since 2.5 is our T, we're going to be adding the 30 minutes before that to make up for the total 18-mile distance that Tasha ran. And so looking at these options here, that's actually going to work with D here. And we can do some plugging in to make sure that that works. So they didn't give us these numbers, but we can use them to double check here. So let's say the distance that Tasha ran is 18. Again, she's going 6 miles per hour. And T is when Alicia is starting. T is going to be equal to, or T is how long Alicia has run, excuse me. And so that's going to be 2.5 hours compared to Tasha's. And we're going to add on 0.5 from there. You can plug this into a calculator or just kind of redo the math that we did over here. 2.5 plus 0.5 is 3. 6 times 3 is 18, and that means option D is going to be our correct solution there. I hope these problems were helpful for the unit test that you're going to be taking, the 1.05 in our Algebra 1 class.